Okay, so today I'm going to just cover really quickly how to do some meshing and textures in GHGL. I want to point out that really to use, I would recommend using 7.0.4, which was just released on April 11th. There were a few texture coordinate bugs that I fixed and some other minor bugs. Okay. So let's start up here. We're going to create a BREP or use a BREP input. Open up a file. Rhino 6 logo. Okay. Set some BREPs. And I'm going to use the GL mesh shader at this time. So the GL mesh shader has one input currently, by default, a mesh. And if I take this BREP and I turn the preview off, and probably want to go in Rhino and or it doesn't matter, just F5 here. And the GL mesh shader is now drawing the BREPs as meshes. So I'm going to go to Rhino, select all, and hide, so I can just see the meshes that are being drawn by the GL mesh shader. Now, what's going on in here is a mesh vertex and a mesh normal are getting passed to the vertex shader, and then the normal is getting passed on down to fragment shader, and the position in clipping coordinates is being converted for the mesh vertex to using the world to clip transformation. And in the fragment shader, I've just got some pre-canned code here to take the normal and the default camera light and just do some standard OpenGL style lighting. What I'm going to do here is I'm going to take this lighting and I'm going to combine it with some textures or a texture. So the first thing I want to point out is I'm going to add a texture here. So let's say image. And then I will use I believe there's a image resource that you can be used, and you can set the local image. And then see if I've got anything here. Here's one from Jeff Lesor. Pass that in. And then in the mesh shader, I want to start off here in the vertex shader, and I need to pass texture coordinates from the mesh down to the fragment shader. So I'm going to add as a built-in the mesh texture coordinate. And then I want this vertex shader to output the mesh texture coordinate down to the fragment shader. So out vec2, since the texture coordinate is a vec2, and say texture coordinate. And here, texture coordinate equals mesh texture coordinate. And then copy this line here, go to the fragment shader, and has to have the same name, but I'm going to have an input in the fragment shader of texture coordinate. Now, the vertex shader is being drawn as triangles. And so every single pixel that's inside of a triangle is being interpolated between the 3 points of the vertex shader. And so the texture coordinates, there's 3 texture coordinates that are involved for each triangle. And as they get passed down the fragment, they get interpolated into another texture coordinate. So that's why you need to pass them down from the vertex shader to the fragment shader. In the fragment shader, I also need to take the image that I've defined here. So I will add a uniform. And the image is a sampler 2D, and I'll call it image since that's what I named my variable. And then down here at the end, I'm going to say, instead of all the code up above, I'll say fragment color equals texture, which is a function in GLSL of image at a texture coordinate. And that resolves to a color. Okay, I'll probably have to hit F5, and that sets up the texture coordinates on the mesh and draws the image at those texture coordinates. So this is really just vec4 pixel color. That's what the texture function is returning, is an RGBA value, and then I could say fragment color, or the output of the fragment shader equals pixel color. Or we could also say this fragment color is going to be a combination of the pixel color and the shading color that we've defined up above. So what I'll do here is I'll say vec4 shading color equals this. And then I'm going to use an OpenGL function called mix, which just mixes two colors, or just mixes two types, really. I'll mix the pixel color, the shading color, and at a mixed value of 0.5. Right, so now I can change this to 0.7, and we can see that there's more of the shading color than there is the pixel color, and I change it to 0.2, and there's more of the pixel color than the shading color. There's other ways to actually get these images. Let's do a panel really quick. So if you have a hard-coded path to an image file on disk, you can paste that in here and pass that into the image, or a relative path if you've got your definition saved in the same directory as an image. Another way you can get the images is just from URLs. So I'm going to go over to Chrome here, and I'm going to right-click on this image and say copy image address. Come here, paste that in, and then use that as my input, and you'll see that it changed. I've got two images of fractals, so it's hard to tell, but there we go. And then let's see, what else can we do here? Let's vary these texture coordinates. So I'm going to zoom in here, and I will, let's see. So let's make a variable called shift. And have a slider from 0 to 1. And in my vertex shader, I'll define a uniform, float, shift, and use that here. So a texture coordinate equals mesh texture coordinate, and I'm going to change the texture coordinate dot x plus equals shift, let's say. Right, so I can actually just shift the texture coordinates on the mesh. And of course, if you want to get really fancy, there's the time here. Could have just done that by going up to the menu, insert time, and I could say shift plus, or no, how about times time, right? Yeah, oops, went to the wrong image. And this will work for all images that you can get online. If you just right-click, copy the image address, paste it in, use that image instead. I'm also noticing that the shading color is pretty magenta, right? So we could also change that in Fragment Shader here. Just add yet another uniform, call it diffuse. Color picker. And pass that in. And in my fragment shader, I'm also going to have an input for diffuse, which is a vec4. Colors are vec4. And then instead of this line here, just comment that out. Just delete it, I guess. And then as we change this, nothing's happening. Yes. Normal position in the fragment shader. Oh, yeah, I've got to spell things right. That helps. There we go. So there you have it. Some different ways to work with images for inputs into these GL mesh shaders. Okay, thanks. Have a good day.